A good place to start is to understand why segmentation exists in the first place, because it is not about making networks complicated for fun. Segmentation is a risk control based on the idea that you should not trust every system equally, and you should not allow every system to talk to every other system by default. In a flat network, once an attacker gains access to one system, it can be relatively easy to probe and connect to many others, searching for weak points and sensitive data. In a segmented network, the attacker's ability to move is constrained because connections are blocked unless explicitly allowed. Beginners should notice that segmentation assumes compromise will happen because it is designed to limit damage rather than to promise prevention. This assumption is realistic and healthy, especially in cloud environments where mistakes and credential theft can occur. Segmentation also supports operations because it creates clearer boundaries for troubleshooting, monitoring, and compliance, making it easier to know what should be talking to what. Another important idea is that segmentation is about controlling pathways, not about hiding systems, because hiding without control is fragile. When you design segmentation well, you create intentional pathways that match how the business works and block the rest. This is how segmentation becomes a practical tool for reducing lateral movement. Blast radius is the concept that helps you measure what segmentation is trying to achieve, and it is worth defining carefully for beginners. Blast radius is the set of systems, data, and functions that can be affected when a particular element is compromised. If a single compromised workload can reach a database containing sensitive data, the blast radius includes that data. If a single compromised account can modify network rules across the environment, the blast radius includes many systems. Segmentation reduces blast radius by limiting connectivity and by limiting what is reachable from a compromised point. Beginners should understand that blast radius is not only about network paths, because identity permissions also shape reachability, but network paths are still a major part of how systems interact. A well-segmented environment makes it harder for an attacker to pivot from one system to another, which buys time for detection and response. It also reduces the chance that one vulnerability becomes an organization-wide event, because the compromised zone becomes a contained problem rather than a doorway to everything. Leaders should appreciate that blast radius reduction is a measurable benefit because it changes incident impact, recovery time, and business disruption. When you design networks with blast radius in mind, you are designing for resilience, not just for prevention. Lateral movement is the behavior segmentation is trying to frustrate, and it helps to understand why attackers do it. Attackers often start with a foothold that is not very valuable, such as a compromised workstation, a low-privilege application server, or a leaked credential. From there, they try to move to more valuable targets, like databases, identity systems, management planes, or systems that can be used to deploy malware widely. Lateral movement can happen through network connections, through reused credentials, through misconfigured permissions, and through management access paths. Beginners should notice that an attacker's success depends on what connections are possible and what trust is assumed. If the environment allows broad internal connectivity, the attacker can scan, connect, and probe services quickly. If the environment restricts internal connectivity, the attacker's options are limited, and each attempt stands out more clearly. Segmentation does not stop all lateral movement, but it forces attackers to find specific paths, which increases the chance that monitoring catches them. It also reduces the number of pathways that defenders must secure and observe. Understanding lateral movement as a goal-oriented process helps you design segmentation that blocks the most likely pivots, rather than simply drawing arbitrary lines. A beginner-friendly way to think about segmentation design is to start with zones based on function and sensitivity, because this aligns network boundaries with real risk. For example, systems that face the internet belong in an external-facing zone, while internal application services might belong in a separate zone, and sensitive data stores might belong in a protected data zone. Management access, such as administrative interfaces, often deserves its own zone because it is high impact and should not be reachable from everywhere. This zoned approach is not about creating dozens of tiny networks. It is about creating a few meaningful layers where traffic between layers is controlled deliberately. Beginners should understand that the most important traffic decisions are usually the ones that cross zone boundaries, because those are trust boundaries. A key design habit is to define what must talk across zones and why, because each allowed connection is a potential attack path. When you justify connections, you avoid the common mistake of allowing broad access for convenience. Zones also make monitoring easier because you can identify unexpected traffic, such as a web-facing system trying to connect directly to a management interface. When zones are defined by function and sensitivity, segmentation supports both security and operational clarity. The principle of default deny is central to segmentation, and beginners should understand it as the idea that traffic is blocked unless explicitly allowed. Many insecure environments operate with an implicit allow model, where internal traffic is generally permitted and only specific things are blocked. That model creates blind spots because it assumes internal systems are trustworthy, which is not a safe assumption when any system can be compromised. Default deny makes design more intentional because it forces teams to enumerate the required connections rather than letting everything work by default. The fear beginners often have is that default deny will break everything, and that can happen if it is applied without planning. But the solution is staged design and careful validation, not abandoning the principle. In cloud environments, default deny is often expressed through security group rules and network access controls that specify allowed ports and sources, and the conceptual idea remains the same even without naming a vendor. Default deny also reduces lateral movement because an attacker cannot simply connect to whatever they discover. They can only connect where rules permit. This changes attacker behavior because they must target allowed pathways, which are fewer and can be monitored more closely. When you embrace default deny thoughtfully, segmentation becomes a real control rather than a diagram. Segmentation design must also consider east-west traffic, which is traffic between internal systems, not just north-south traffic to and from the internet. Beginners often focus on blocking the internet, but many attacks spread internally once initial access is gained. East-west controls limit how internal services communicate and are therefore crucial for reducing lateral movement. A common mistake is allowing broad internal connectivity because it makes deployments easier, but that convenience creates a flat internal network where attackers can roam. A better approach is to allow only the specific service-to-service connections that support the application architecture, such as allowing a web tier to talk to an application tier and allowing the application tier to talk to a database tier. Another mistake is forgetting about management traffic, such as remote administration paths, which can become a high-risk east-west channel if it is reachable from many places. Beginners should also understand that some internal services have high value, such as identity services and key management functions, and those should be segmented more strictly than general application components. When you design east-west rules, you are effectively drawing boundaries around trust and privilege. That boundary drawing is how segmentation reduces blast radius, because a compromise in one tier cannot easily jump to every other tier. Cloud segmentation also interacts with identity and access control, and beginners should understand that network boundaries are not the only boundaries in cloud environments. In the cloud, identities can sometimes bypass network restrictions by using management APIs to create new resources, attach network interfaces, or modify rules. This means segmentation must be paired with strong identity controls so that an attacker cannot simply change the network to undo your segmentation. Least privilege for cloud administrative roles is therefore part of segmentation success, because if too many identities can alter network policy, segmentation becomes fragile. Another important interaction is with service-to-service authentication, because even if network rules allow a connection, the application should still authenticate and authorize the request, creating defense in depth. Beginners should see that segmentation is not a replacement for application security, but a layer that limits pathways and reduces the damage when other layers fail. This layered mindset is especially important in cloud because changes are fast and mistakes propagate. Leaders should also understand that segmentation needs governance, such as reviews and policy gates, so network rules do not drift over time toward overly permissive patterns. Without governance, segmentation tends to decay because teams open pathways for convenience and forget to close them. Segmentation works when it is treated as a living architecture, not a one-time setup. Another concept that matters is segmentation for environments and workloads, because mixing different purposes in the same network space creates unnecessary risk. Development and test environments often have weaker controls and more experimentation, and if they are too connected to production, they can become an indirect path into critical systems. Beginners should understand that environment separation is a form of segmentation that reduces blast radius across the software lifecycle. Similarly, separating workloads by sensitivity can prevent a compromise in a low-sensitivity service from reaching a high-sensitivity database. This does not mean every environment must be isolated with no connections, but it does mean any connections should be deliberate and monitored. Another common mistake is allowing shared administrative access across all environments, which allows an attacker who compromises a low-risk environment to use those credentials to access production. Segmentation must therefore consider administrative pathways as well as application pathways. Beginners should also recognize that segmentation can be expressed in logical groupings, such as separate accounts or projects, which adds another boundary beyond network rules. Even without vendor detail, the principle stands: separate what should not automatically trust each other. When environments and workloads are separated deliberately, recovery becomes easier because incidents are contained within a smaller scope. Monitoring and validation are also essential to effective segmentation, because segmentation that exists only on paper does not reduce risk. Beginners should understand that segmentation should be tested by confirming that only intended paths work and that unintended paths are blocked. This includes checking that internet exposure is limited where it should be limited and that internal connectivity matches the intended architecture. Monitoring should look for violations, such as unexpected connections between zones, which can indicate misconfiguration or attacker activity. Segmentation also creates a useful baseline for detecting anomalies because when the allowed pathways are narrow, unexpected traffic stands out. Another important monitoring focus is rule changes, because attackers and mistakes can alter network policy, and those changes can undermine segmentation quickly. Leaders should ensure there are controls around who can change network rules, and that changes are reviewed and logged. This ties back to infrastructure as code practices, because using code-defined network policy makes changes traceable and reviewable. Beginners should see that segmentation is not only design, it is also operations, because networks change as systems change. Without ongoing validation, segmentation decays and blind spots return. When you step back, designing cloud network segmentation to reduce blast radius and lateral movement is about building an environment where compromise is expected but contained. Segmentation divides systems into zones based on function and sensitivity and controls traffic between zones so only necessary pathways exist. Default deny principles make connectivity intentional, and east-west controls limit internal roaming that attackers rely on for lateral movement. Segmentation must be paired with strong identity controls and governance, so network policy cannot be easily bypassed or quietly weakened over time. Separating environments and high-sensitivity workloads reduces the chance that a low-risk compromise becomes a high-impact event. Monitoring and validation ensure segmentation is real, enforced, and resilient as the environment evolves. For a beginner, the most important takeaway is that segmentation is not about making networks complicated. It is about making pathways predictable and limited so that when something breaks or gets compromised, the damage is smaller and the attacker's movement is harder. When you design segmentation with these principles, you build cloud environments that are easier to defend, easier to monitor, and far more resilient under real-world pressure.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.